In this video we will see free body diagram. Definition is a diagram that shows the particle with all the forces that acted on it. Means we have to make a diagram where we have to show all the forces that is acted on it, and the diagram is called as a free body diagram. The first step to draw a free body diagram is we have to make a isolated or free. We have to isolate the body or free the body from the surrounding and draw the outline of that body. If we have to analyze the body, we have to draw a diagram of that body which is isolated from the surrounding. The second step is we have to show all the external forces that are acted on it. Forces can be known forces which are given externally in the question, or the unknown forces which are generated due to the reaction forces. So we have to show all the forces that are acted on this drawn diagram, and we have to identify proper direction and magnitude of known forces and direction of unknown forces. Direction means the line of action of the force which is acting, so that we have to find those unknown forces. We have to just draw the line of actions, and we have to assume any of the direction, and we have to draw known and unknown forces on the diagram. After that, we have to apply the equilibrium equation, which is summation of f is equal to 0 and summation of moment equal to 0 in all the three directions. Means summation of f x is equal to 0, summation of x y is equal to 0, and summation of f z is equal to 0. Similarly, three equation for moment. And if it is a 2D diagram, means it's a planar diagram, then summation of fx equal to 0, summation of fy equal to 0, and summation of moment in z direction equal to 0. So the three equations we get in 2D diagram and 6 equations we get in 3D diagram. So we have to apply the equation, equilibrium equation, and we have to find the unknown forces acting on the body. So that is how we can solve the free body diagram problem in statics. And one example we will see is here. So here we have this wall, and at A point there is a rope connected which is passing through this pulley at B, and from here it is connected to C point where there is some mass connected, and on the other side there is a spring connected, and this spring is connected to this vertical wall. So if we want to analyze this, and we have to draw free body diagram each and every element, and we have to apply equilibrium equation on all the elements to find unknown forces at various sections. So first if we consider this point, so in this rope, this is connected at the wall at A point, so there will be tension in this rope, which is denoted by T1, and here there will be reaction at A. So if we apply the equilibrium in this direction, or in the direction of the rope, which is x dash direction, so if this is x dash direction, then x dash will be summation of f dash equal to 0, which will be Ra equal to T1. So we can get this reaction force equal to the rope tension. Now if we draw a pulley diagram, then there is a rope connected on both the side, and there is one force which will be generated by this member. So here let's say the member is generating the RP force on the pulley. So this force on the member will be downward direction due to the weight, and on the upward direction due to this member. So in the pulley there will be upward force which is RP. So here RP is upward direction, this tension in the rope will be in this direction, and there is one on the other side. The tension will be equal to this tension only, because the rope is connected without any other force. So this T1 will be transferred through the pulley on the other side. So here also there will be T1. Now if we isolate this rope and we analyze the C point, so C point has three different ropes. One is going on the pulley side, one is on the spring side, and one is on the mass side. So if we draw like this, then there will be three different tension in three different direction. So here T1, which is equal to this, because we have taken section here, so that must be equal, and this T3 is going on this side, in the spring side, and T2 is on the downward side. So if there is this, we got the section here, we get T2. So similarly on the mass side there will be T2 tension, and there will be weight of the mass will be acting W equal to mg. So if we apply summation of Fy on this mass, then T2 will be equal to mg. So this is how we can apply equilibrium equation. Here we can apply summation of Fx equal to 0, but there are no forces and also moment is not present, so that also are valid. So we have to choose appropriately which equation we have to use. This T3 on this side will be equal to the rope on the spring side. So this T3 will be equal, and the spring will also be having summation of Fx equal to 0. So T3 will be equal to spring force which is generated inside the spring, and both will be equal. Now this is also connected to the rope on the wall. So this T3 will be equal to reaction at E point because of summation of Fx equal to 0. So reaction E will be equal to T3, which is equal to the spring force. And so this is how we can apply equilibrium equations on various objects, and we can isolate different objects, and we can also connect these 2 points directly without breaking it. So the internal forces will be cancelling out each other T1. Still there will be still all the equation of equilibrium will be followed. So this is how we can apply equilibrium equation, and we can draw free body diagram, which is extremely important for static problems. And lot of questions each and every year there is one question from this topic. So practice these questions, and see you in the next video with some more insights to this. Thank you for watching this video.